Hi there, this video outlines a specialized type of multiplication that's seen in bacteriophages. So bacteriophages are a type of virus that infect bacteria, and they have one of those complex structures outlined in other videos. Now, this is not to scale, but because viruses, even though they are very small, bacterial cells are also very small too, and don't have some of that machinery for viruses to easily come over the cell like we see in animal viruses. So the adsorption and penetration step actually uses an injection mechanism. So we'd still have our adsorption or attachment where the virus locates the appropriate match for the host cell type. Then for penetration, it's very different where in animal cells we saw the virus actually coming over the cell membrane. However, here what we're seeing is what's called injection. And I often think of that sort of as a syringe. As the proteins bind to the surface, the proteins have to change or form to sort of send this nucleic acid over. So remember, this is our nucleic acid here. And then once inside the cell, fairly similar to synthesis and assembly. Now remember, there's no nucleus that's there, but you would have synthesis, assembly. Okay, so that's our steps 3 and 4. And I'll talk about an alternate here in a second. And then finally you would have, and some people use the term maturation for that final assembly that's there. And then you would build up enough copies that the cell would lyse. And that would then release these fully formed virions. There isn't an exocytosis or budding mechanism, anything like that, for these to be released. So eventually this cell would literally have to rupture open, kind of make a rupturing there, and these viruses would then be released that way. Okay, so that's one route. Also, viruses can go into sort of a dormant type phase, and typically those are called temperate phages. They'll go into what's called a lysogeny or lysogenic phase. This is just simply an alternate. So instead of that synthesis and assembly, it comes from, and I probably would be better to draw that coming from over here, coming from the nucleic acid. That nucleic acid turns into what's called a prophage. And it gets incorporated, so this is an alternate pathway. So it gets incorporated into the bacterial chromosome, and I'm going to make the bacterial chromosome look like a simple circle here. Of course, we know it's normally supercoiled, even though it is circular. So I'm going to bring this pink over here to show that viral DNA going into that. And so it'll actually get incorporated into the host cell. And so this is lysogeny. Now, it can remain in there for quite some time, and this may be a way, as the cell's undergoing binary fission, the bacterial cell, it's a way to actually make copies of itself, because here it's going to kill the cell. So it's kind of one virus, you get a lot of copies out, but you're getting into one cell and that's it. This would be a way to pass that genetic information into multiple bacterial cells, and then it can be triggered, and that's called induction. It'll be triggered to start making copies of itself. Some other kind of related things to lysogeny, that you can have what's called lysogenic conversion. And this is where the bacterial cell will actually be expressing some of the viral genes. So for example, some viral toxins could be expressed by this bacteria, and now it suddenly increases in virulence. So maybe it was able to cause disease before, but now it makes this additional toxin. So it's from the bacterial infection, but it's because it's carrying that viral DNA. The other possibility would be transduction. which talked about a little bit before, and that kind of really overlaps with both of these cycles that are here. But transduction is when a virus enters a bacterial cell, but actually instead of just bringing its own nucleic acid, brings nucleic acid from a neighboring host bacterial cell. And this is a big way that bacteria exchange genetic information. So you can imagine in looking at this lysogeny phase, when this is packaged back up to make copies and make new viruses, some pieces of the bacterial DNA could come with it. Another possibility is during synthesis and assembly, because it's so rapid. And even though the virus is commandeering the bacterial cell's machinery, perhaps it takes a little bit of bacterial DNA with it, packages it up. So maybe some of these that come out, so if we've got our nucleic acid from the virus, maybe there's some from that bacteria that gets accidentally packaged up and taken out with it. Now, when this infects another bacterial cell, it will take that bacterial DNA with it. So that's kind of related to that. We've talked about that more in terms of horizontal gene transfer between bacterial cells, but this is at the kind of viral mechanism level, how that would work that's there. So bacteriophages are a little bit different in the sense, oh, and I didn't label release here, I apologize. And so this penetration phase really includes uncoating. They're kind of the same, so I need to kind of lump those together there. So our last phase here, release, and you can put this into 6 steps if you want to make that number 3, would be this these viruses being released. So back to that, so the absorption, what's the key differences here are the absorption and penetration, because only the nucleic acid gets over the bacterial cell membrane. Synthesis and assembly, a lot of similarities there to animal viruses. We don't see enveloped options, so the only way out is going to be lysis. Okay, we don't have exocytosis or any of those other things. And then other times these bacteria can go into what's called the lysogenic phase. So after the penetration and uncoating, it will, that piece of nucleic acid, let me label that there, and that's typically called prophage, gets incorporated into the bacterial chromosome. And that can do a few things. So it can just sort of kind of sit in there and kind of hibernate a little bit until it's triggered to start making copies of itself. But by that time, this has been copied into many daughter cells. It also can do what's called lysogenic conversion, where it kind of remains in there, and that can contribute to pathogenicity or virulence. It really contributes to virulence. And then finally, transduction is another related to both of these processes, because transduction is that accidental packaging up of bacterial DNA, and you could see that could happen here as well when it gets triggered again to start to undergo multiplication and enter that lytic cycle. So it'll accidentally package that up. It'll come out here, and then it could inadvertently, well, when it infects the next bacterial cell, it inadvertently transfers that over. That's one way that genes are transferred between bacteria. And so these are all the kind of functional phage nucleic acids there. So it's just kind of an overview of that. Again, I always like that you watch the animations as well to really just, see this in motion so you can get a sense of these steps. I thank you very much, and this is Corey Andres for CN.